Okay, I am going to go through this problem. It is very similar to, actually it's exactly like all the problems, most of the problems in this section, just different numbers, okay? So if we conducted a survey of 30 programs, all right, all the population information, of course, this would be the mean of the population right here. It's 162,000, all right? That goes here. That is the easiest one. You just put the mean of the population right here, okay? And the standard deviation is 38,000 that they give you, okay? That goes here, so that's really easy. So that is the population information, A, all right? That's the big X. Big X is the population. Small x bar is evaluating the sample distribution, okay? All right? So for the sample distribution, the mean is the same as the population, 162,000 in this case. However, the standard deviation is what changes from the population to the sample distribution, okay? The population here is 38,000, that's given. The sample distribution, standard deviation, is given by the equation of this. The standard deviation of the sample distribution is the standard deviation of the population, which is given in the problem, 38,000, divided by the square root of the sample size, okay? So when they went in here, they said, suppose you take a sample random of 12 graduates, all right? That's the sample, okay? So the sample size is 12 of our distribution. So again, the mean is the same. So we go back and we take 38,000 divided by the square root of 12, because 12 is a sample size, 38,000 is the population standard deviation, and we get our standard deviation for the sample distribution of those 12 schools of 100 and looks like 10,969,000 and some change, right? Okay. All right. So that's part A and part B. So the only thing different in part A and B is from what's given in the problem is that calculation highlighted there. And of course that is given by this equation, and that equation turns out to be that, okay? All right. That does that. Okay, so now for a selected graduate, find one graduate, okay? So the square root of 1 is 1, correct? And anything divided by 1 is that number. So when we do this part of the problem, we do just like we did in chapter 6, the prior chapter, but we use, because if we look at this formula right here, square root of the sample size, okay? Square root of the sample size, right? Okay? Well, they said for a single randomly selected graduate. So for this part of the problem, we do exactly what we did in chapter 6, exactly, no change. And we use, this as our standard deviation, because 38,000 divided by the square root of 1 is 38,000. And of course, our mean is the same. So we go to Excel, and remember in chapter 6, if hopefully you remember, it wasn't that long ago, we do norm inverse. We find the probability for, no, norm.dist, I'm sorry, norm.dist. We find the probability for that, and we find the probability for that, and then we subtract one probability from the other to find the answer. So let's see. So what they're saying is if I randomly select one graduate, and the probability that that one graduate is between 165,000 and 181,000 is what? What is that probability if I select one graduate, okay? So I go in here to Excel, and I do the formulas, I do the more functions, statistical, just like we did in chapter 6, and use the norm.dist, and the X is we'll do the lower one first, 165,846, okay? The mean is 162,000, okay? The standard deviation is what's given in the problem, because it's only one sample, okay? And the cumulative is always 1. So there's the answer to the lower number, okay? Now we're doing the probability for lower, all right? So now we find the probability for higher. We do the same thing, except we use the 181,000 number given in the problem, okay? So, so we just found the probability less than that number, okay? Remember, Excel always does less than. Now we have to find the probability less than that number, and then subtract the two probabilities from each other, okay? And again, we're still just using 38,000 as the standard deviation, the one given in the problem. So we go formulas, more function statistical, and we do norm.dist, and we do x. This one is 181,731. 181,731. The mean, again, is 162,000. The standard deviation is 38,000 given in the problem. Okay. And cumulative is 1. All right. Whoa, what happened? Okay, so then we get this number right here. All right, when we do that. Okay. The x value is 181,731. The mean is 162,000. Standard deviation 38,000. Okay. Now we subtract one from the other. Remember, I always tell you in Excel, you may as well do it in Excel, equals. You can do it on your calculator if you want, but it's a lot easier. You have it right here. It equals this minus this for your answer. Okay. And 0.1579 looks like. Okay. 0.1579. All right. So basically, all we did was use the norm.dist to get both this number and then subtract one from the other for your answer. Okay. Answer part C. Okay. Now they ask for for a simple random sample of 12 graduates. Okay. Now we're grabbing the 12 graduates. All right. Find the probability between this and this. Now remember, for the sample distribution of 12, the mean is the same. However, this is the standard deviation we're going to use for part D. And we're going to do the exact same thing as we did for part C. And the only difference is we're going to use this standard deviation we calculated in part B as our standard deviation. All right. So I'm going to go back in here and we're going to do, I have to write that down. So now we're going to do the exact same thing we did in part C. No different. We're just going to use a different standard deviation. That's it. It's not, like I said, it's not that difficult. Okay. Norm.dist. And again, the x, we're going to do the 165,846. The mean is 162,000. The standard deviation is the one calculated in part B, not the 38,000, the 10,969.6551, okay? And the cumulative is always 1, all right? So that's the lower, okay, for part D. P for lower, all right? Because remember, Excel always does less than. Now we do the P for higher. Same exact thing. We just used the 181,000 number. So formulas, more functions, statistical, norm.dist again. This time the x value is 181,731, which is given in the problem. The mean is 162,000 given in the problem. Standard deviation, we calculate it. Remember, you have to use the new standard deviation, so to speak, 10,969.6557, and cumulative is 1. Okay, and that's it. So then that's the P for higher, and then again you subtract the higher from the lower. So just like we did the last time, equals this minus this to get your answer. 0.3269 looks like, okay? 0.3269, all right? And for part D is the assumption of normal necessary. In this case, the answer would be yes. All right, I hope that clears up any questions. This is not that difficult, so please let me know if you have any more questions.